Hi everyone, welcome back to the third episode of game development tutorial with C# and OpenTK. Today we are going to work on actually getting something on screen. I'd like to make a little triangle and render it. That would be great, so then we can finally see something. But it's only the third episode, so I guess we did it quite quickly. But it's all a little bit messy, and that's going to continue this episode, the messiness. So if you want to get straight into the action, please, there should be a timestamp somewhere around now. And otherwise we are just going to do a quick recap of what we did last episode. Last episode we worked on getting the window ready, so we made sure that we can do this. There we go. Nice blue screen. If I click on it, it turns to different color. Different click, different color. So we also added all the necessary events. So update, render, mouse down and key down events. Right. So then this episode, like I said, will be a little bit messy still because I am going to put everything that we need to render a triangle right here in the constructor. That's just not that great. But in the next episode I will start moving everything over to our engine. We're actually going to use our engine in the next episode. Alright, so that's it. Let's get into it. Okay, so what do we need to make something appear on screen? Well, I prepared some paint right here. Right. So pretend this is our screen, all the white space here. Now, if we want to make a triangle, right? So something like this, something like that, and like that. There we go. It's not that straight, but we are going to pretend that this is the x-axis and this is the y-axis. Right, and then this, the middle of the triangle, is going to be the origin of our screens. This is going to be 0, 0. There we go. Right, so how are we then going to make a triangle? Because of course we need to tell our graphics card exactly where to draw it and all the information that it needs to draw. So yeah, where to draw it and what to draw and in what order to draw it, and well, you could even tell it what color you want it to have or what lighting effects you want it to have. But for today we're going to keep it simple. No colors, no lighting, no nothing, just a white triangle. Alright, so it just needs to know the positions then. So what if we would give it these 3 vertices and then tell it to render them in this order. First this one, index 0, then this one, index 1, this one, index 2. And that's it. And then it needs to draw a triangle with these, so then it can just connect the dots in that order and create a triangle. That's pretty much what we're going to do. Now, this is going to be like about x0, y1. This one here, let's just look at that. Oh, this is going to be about x negative 1, y negative 1. And this one's going to be about x positive 1, y negative 1. There we go. So what we need to tell the graphics card then is, we need to tell it, alright, we have vertices. And those are going to be, first one is going to be 0, 1. The second one is going to be negative 1, negative 1. And the last one is going to be 1, negative 1. And it needs to know the order, and the order we are going to convey that information using so-called indices. So right, so it's just going to be 0, 1, 2, because this is going to be 0, that is going to be 1, and this is going to be vertex 2, and then just connect them right in that order. Aha. We could also do it like this. Make this two, make that one, then it will pretty much switch these two around. So then it will draw like this instead of like that. But why would you? Keep it simple. Yes. So now we are actually going to get into some OpenGL stuff. Keep this in mind. That's pretty much what we're going to make right now. Alright, so we'll do that right here. So we are going to work with floats because that means that we can have something. We wouldn't need to have it at 0 or 1, we could do 1.5 for example. That's just nice, gives you a little bit more freedom, so we're going to use floats. Vertices, we are just going to make that a new float array. And then exactly like this. We're just going to do 0, 1, negative 1, negative 1, 1, negative 1. There we go. Same thing with the indices. We're just going to copy what we just did in Paint. 0, 1, 2. Oh, there we go. Right, that was easy. Are we done? Well, not completely. OpenGL still has no idea what it has to do with this. So the graphics card has no idea what to do with this. Doesn't even know this exists, so nothing's going to happen. Right, so we need to somehow tell OpenGL first what to do, and then we need to send that to the graphics card. Alright, OpenGL has a few tricks for that. We have something called gl.gen buffers. We can even do gen buffer. Let's just do that. So it will create a buffer for us. And a buffer is pretty much just an array pretty much. And we can store information in that. So we are just going to create one buffer, one array that's going to store all the vertices, and one's going to store the indices. So I'll need to do that twice. Now the indices I'll need later, so I might as well just put something right here, private int, and then index buffer object. That's pretty much what most people call it, so we'll use that too. So the first one will be our index buffer object. It's going to be gen buffers. So you might notice that, alright, but if a buffer is something like an array, why are we getting an int from this method? Shouldn't it give us something like an array or a buffer object? Well, OpenGL just kind of like hangs on to its own buffers. It doesn't want to give you the buffers directly, so it just gives you an ID for the buffer. So it's just going to be a number. And then we can tell OpenGL later that we want to manipulate the buffer with this particular ID, and then it can do that. Alright, we also want something like a vertex buffer object for the vertices, but we won't need that anywhere else in our code than in the constructor, so we'll just put it right here. No need to put that outside. Aha. So now that we have this, we would like to actually put this data into these buffers. Alright, how are we going to do that? We are first going to bind a buffer. So that's just going to tell OpenGL, hey, I want to use this buffer right now. Let's start with IBO. That's not working. Oh yes, of course. We also need a buffer target. That is going to tell it what type of buffer it is. So it can be an array buffer, atomic counter buffer, copy read buffer, all sorts of things. We will need a element array buffer. Right, so the index buffer object has to be an element array buffer type. It doesn't specify exactly what that means, but it doesn't really matter. Then we will need to actually put in the data. So what we can do is we can do, oh, that's not what I meant to do. GL buffer, buffer data. There we go. This is going to take in a buffer target. That's the same as this one. So it's just again going to specify what type of buffer it is. Then the size. The size is pretty much how large your buffer has to be in bytes. So what we can do is, well, we know that this is 1, 2, 3, 4, 5, 6 long. 6 long, but they're all floats. And we want to know the size in bytes. So what we can do is we can use size of float. There we go. Size of is just going to return the amount of bytes something takes. And float is going to return 4, almost always. But maybe on some systems float would automatically be 8 bytes. So just to be sure, you might want to just use size of instead of use 4. What we might also be able to do is use size of vertices. Maybe not. It's not a predefined size. Yeah, okay. So we can't use that. So we could use then vertices dot length times the size of float. We could do that. So we're just going to check for the length of our vertices and then the size of a float. This will always work. We can manipulate this. Oh, we can manipulate this as much as we like, and this is always going to work. So we might as well, right? Okay, is it 6 again? Yes, okay, nice. Then, let's see, what do I need then? I need the actual data, yes, of course. So I'm just going to put in vertices, that's the actual data. And then how are we going to use that data? So buffer usage hint, and we are going to use it in static draw. Now what this means is, because you could see there were many different ones like dynamic draw, why not use that one? Draw means that you are going to use this data to actually draw something on screen. You can also make these buffers and just store all kinds of stuff in it. But we are going to use it specifically to draw something on screen, so that's why we use draw. And once we now create this buffer, we are not going to change it anymore, so that's why it's static. There are also like dynamic draw, like I just showed you. That would mean that we might want to change the data inside of this buffer at some point, but we don't. So then using static draw is faster, I believe, or better for memory, something like that. That's that. Now we need to do the same thing for the vertices. So this was for the index buffer, remember that. So I'm just going to put that there. Now we need something similar for the vertex buffer. Now we can copy a lot of this stuff. Of course we need to first bind the vertex buffer, because it needs to know what buffer to use. But the vertex buffer is, well, just going to be an array buffer. It's not going to be an element array buffer. There's a difference, like a subtle difference. It has to do with usage, how you're going to use the buffer. But yeah, array buffer for this one, important. Then we pretty much do the same thing, honestly. Oh wait, I put vertex.length. This has to be index.length and then size of int. There we go. And then indices. Okay, yeah, I kind of messed that up, but that means that this is already correct. That's great. That's great. So yeah, use the right data. That's important, believe it or not. I don't think that there's a difference between the size of integers and floats, but still, put that in there. And the vertices, then put the vertices in here. Yes, this should be correct. Okay. But let's say we also kind of want like colors in there, and let's say we also want the lighting in there. Now then we would need to make 2 other buffer datas, and then we would have to bind all those buffers together in some way and then render that. That's just not nice. So what they decided to do was to make another form of a buffer. Or an array actually. It's called a vertex array object, and that is pretty much going to combine all the data a vertex needs. So it's position data, which we just have in here, the position data, but also other data like colors and lighting and all that kind of stuff. Right now we're not going to use that, but we will in the future. So we are going to use vertex array object. I'm actually not quite sure if you could, if you really wanted to use only the buffers for this. I'm not sure if that is possible, but I guess we won't find out this episode. So vertex array objects pretty much work kind of the same way as like buffers. What we need to do is we need to just go do the gl gen vertex array. There we go. Now we have a vertex array. What we then have to do is put the data in the vertex array. Do keep in mind that this is only going to be the vertices, the vertex information. The indices are not important to the vertex array object. It doesn't want this. It wants the data of a vertex, and the order in which vertices are drawn are important later. By the way, I put this in here because obviously we're going to need that to actually draw everything, and we're going to draw everything in the render method. So vertex array object, just like the index array, now the index buffer object needs to be outside. A lot of buffers and array objects here. A lot of difficult words. Alright, anyway. Let's do this. So indices, just keep that as is. The indices just work now. They are good. We just need to put the vertex buffer data inside of the vertex array object. Alright, let's do that. So what we need to do is we don't only need to bind the buffer here, we also need to bind the array. Bind vertex array. It's pretty much the same thing. Good thing you don't have to specify what type of array it is. It's always the same thing. So that's nice. Right, now we need to put in a vertex attribute pointer. Right, so this is just going to connect the buffer with the vertex array. What it needs to know is, it first needs to know, let me see, the index. That's just the index. It's going to start looking in the buffer. So let's say you have a bunch of like trash data in front of here. You could say, alright, you should just start at like index 6 or something, because in front it's just going to be trash, you don't want that. But in our case it's all neatly packed, so we're going to start at 0. Then it needs to know the size. The size is not the same as this size. It is the amount of data per vertex. In this case it's going to be 2 pieces of information per vertex. One for the x coordinate, one for the y coordinate. That's going to be 2. Just 2. It's also, yeah. Now it needs to know, well, what size is one piece of data in bytes. Because like we did here, we said here just, well, floats are 4 bytes. So now just look for 2 bytes. Well, that's not good because it's 8 bytes, the first 2 bits of information. So we need to tell it again that it has to deal with floats. Don't know why they didn't just ask for another number like they did here. I could have just put that in there and then it might have worked too, but I guess not. Anyway, that's fine. Maybe it just needs to know that it is specifically a float for drawing. I don't know the exact details, I'll be honest with you. Now, what's this? I wanted to write false because yes, alright, normalized. It's not normalized. Normalized just means that every bit of data combined results in 1, but this is 1. This is going to be square root of 2. This is going to be square root of 2. If you would if like a vector pointing at that location, then the vector length here is going to be square root of 2, because this is 1, this is 1. There we go. Pythagorean theorem right there. Cool. Yeah, so it's not normalized. That's completely fine. I don't know exactly what the advantages are for normalizing, but well, we'll see. Stride is how much trash data is in between two consecutive data points. So again, I could have a bunch of trash data in between here. I could say, well, maybe like need to skip 5 bits of trash data and then read it again. But again, everything is tightly packed. Everything is really nice, so nothing to worry about. And then offset is again something like having a bunch of trash data here somewhere. We don't have that. 0. Good. Great. Now the last thing that we need to do here is we need to say gl dot enable and then vertex attribute array. There's also vertex array attribute, not that one. Need to get the vertex attribute array. Very confusing actually. I got that one wrong a few times. Needs to be 0. What is this and what does this mean? I'll tell you straight up, I'm not going to explain that this episode. This has everything to do with shading, or with the shader. We are not going to make our own shader in this episode. We're going to do that in the next episode, and then everything that is actually happening inside of the graphics card is going to be much clearer, and you will understand why you need to enable this. But for now, you don't need to. Just enable 0 and you're going to be fine. And yeah, I really want to get into that. I really do, but it's going to be very vague as long as I don't actually have a shader to point to and to work with. So next episode I will owe you that one. Right, so that's everything that we need to do in the constructor. Everything here is fine. We have our index buffer object and we have our vertex array object. Nice. Now we can render them. In order to render, we need to bind these objects. So I need to bind the VAO and I need to bind the IBO. And then of course this is going to be an element array buffer, because we use that here too. The IBO is an element array buffer. It's just what it is. And after we draw something, I also want to unbind them, and you unbind something by binding 0. 0 is just it's just like null, binding null, so it will unbind anything else. So that's great. Yeah, you don't have to do this, by the way. You don't have to unbind right now, but if you are going to work with a whole bunch of different vertex array objects and a whole bunch of different index buffer objects, you might as well unbind just to be sure. Otherwise you have a risk of weird things happening, like index buffers being mixed up, and then oh boy, you can get some weird stuff drawn on screen. Anyway, now the real deal. Draw elements. This is the actual method that is actually going to draw something. Finally. Alright, what does this need? It needs a begin mode. Begin mode. So it needs to know what it's going to draw. Going to draw quads, a polygon, points, patches, lines. We're going to draw a triangle, so just put in triangles. Then it needs to know the count, that is how many vertices it's going to draw. Or I believe it's the amount of indices it's going to draw. So you're going to pass it a buffer that maybe has like 300 different indices in it. And with this it will just draw the first 3. Alright, and then it needs the draw element type. Right, unsigned int. This is the type of data that is inside your index buffer object. So we made this, the indices, an int array. We actually even make it an unsigned int array, but it's fine, I guess. So we made it an integer array. So that means that it needs to read it as an integer array and not as a short or a byte array. And then indices, put in 0. Actually looked it up for this episode. Indices is Well, if you don't want to do all of this stuff, you just don't want to make a whole index buffer object, you could, if you wanted to, just put the whole thing right in here. That would work. But you can see that I get like a green line because it is obsolete. It doesn't work anymore. It's like deprecated. So, well, it does work actually, but it's obsolete, it's deprecated. Don't use it. There's pretty much no reason unless you're really lazy. And we are not really lazy, only slightly lazy. So, there we go. Just put in a 0 and it's all fine. This should be it. This should be it. I don't know if I already told this, but just something important. Initialize your window first before you call any OpenGL method like clearcolor or even gen buffers or gen vertex array. If you don't do that, if you initialize the window later, you might even crash, and if you don't crash, then you will at least not see anything on the screen. Like nothing will work. In the constructor of game window, a new OpenGL context is created. So OpenGL is only available after you create the window, because OpenGL interacts directly with the window, so to speak. So that's important. Now, the big reveal. Is it going to work? Let's check. Aha, there we go. There we go, a white triangle. It's exactly what we wanted. Now, you'll notice that it touches like the edges of the screen pretty much perfectly. So the screen, the default drawing area on the screen is a 2 by 2 square with the origin directly in the middle, so you can go one up, one to the left, one down, one to the right. That's why we made it in these proportions. So that's pretty neat. Now, you can also make some other things, just to close things off here. So we said, let's make a triangle, right? But we can also make lines. We can even do a line loop. Right, let's see what that does. There we go. Now instead of a fully filled out area, we just have, well, you can't really see this bottom line, but trust me, it's there. Yeah, and if you, oh, well, that's nice. Anyway, so you can change the area by just changing this, I guess. Well, that's nice. Anyway, so you can't really see the bottom line, but now there are 3 lines instead of an area. So in that way you can actually draw a whole bunch of different things. That's how OpenGL can interpret the same data in a very different way with a very different effect. So that's that. We did it. Next episode we are going to put all of, well, this stuff and all of this stuff over in our engine, and we are going to create a shader. Shaders are pretty much the instructions for a graphics card. Right now it does actually use a shader, even though we haven't told it to. It uses like a default shader program. Now we'll make our own, and then we should be able to make colors. I don't think that the colors are going to be implemented next episode already, because it's already going to be a lot of work to create the shaders. Episode after we'll probably do colors too, so then we can make a color triangle, and everything will be in the engine, which is great, because then the code looks a lot cleaner than it does now. It's really bad to just do everything in your constructor. So great, that's it for this episode, I guess. So then I will see you guys in the next one. Have a great day.